Yeah, good evening, everyone. Now, as part of the sixth semester, we are understanding the subject data structures using Java. Data structures using Java. Now, as part of this course, we will understand the following topics. These are the topics we will understand. The block one. The block one, we'll understand what are the lists and tags. And block two, we understand the queues and trees. And in block three, we understand hashing and heaping. And block four, we'll understand searching and sorting. So these are the topics we'll understand as part of this course. So you know that the subject name is data structures using Java. Data structures using Java. Now, as part of the first topic, now actually the topic is a mathematical review on analysis of algorithms. This is a topic, a mathematical review on analysis of algorithms. Now, as part of this, we'll understand what is the objective of this topic and introduction and algorithms and analysis and what is space complexity and time complexity, the mathematical notations of algorithm analysis. So these topics we have to understand. Now, first and foremost, we understand is objectives. What is the objective of this topic? A mathematical review on analysis of algorithms. Now, as part of this topic, we understand is so concepts, the examples, examples of that algorithm. Now we'll understand even what is the time complexity also, and we understand even space complexity. So these are all. So that is an objective of this topic. Next one is introduction. Introduction. Next one is introduction. Now see is part of the introduction. Is part of the introduction. What is an algorithm is? What is an algorithm is? So this is very important to understand before understanding data structures and before understanding Java. So what is algorithm here is? Algorithm is a precise, what is it? A precise rule. It is a precise rule. Means what? It is a set of rules. Set of rules and precise rules means what? They are countable. Means what? 1, 2, 3, like that, so on. It is so on. So set of rules or precise rules means it is countable. The rules are countable. It is not that uncountable rules, or it is not that unlimited rules. Okay. The rules are countable. Clear? So an algorithm is what? It is a precise rule or set of rules. So when I say set of rules or precise rules means the rules are countable. So the rules are countable here means that can be 2 rules, that can be 5 rules, that can be 10 rules, that can be 100 rules, like that. There is some kind of count. So what the rules are specifying then? So they specify that how to solve some problem. What they are specifying? How to solve some problem. So I would like to go from one place to another place. Okay. I like to go from one place to another place. So to go from one place to another place, we have some rules. We have some rules. Okay. We have some rules. By following the rules, we can complete the task. By following the rules, we can complete the task. We can complete the task. So the task is what? I want to travel from some place to some other place. Okay. Here this is the transportation is that can be non-stop. That is non-stop bus. That will take only source. It will start and it reach the destination. It doesn't stop anywhere. In the middle, it doesn't stop anywhere. Directly it go to the final destination. One single step. So here the algorithm is having only one step. The same travel, if you select the express, okay, if you select the express, the stopping points are that can be 1, 2, 3, 4 like that. Depending on the distance it is traveling. So it is when you select the express bus. Now when you select the ordinary bus, okay, same distance, same source, that will take 10 steps. I mean 10 bus stops. It will stop at 10 bus stops. Okay. So see here, the same source, same destination, the different traveling medias, they are taken different kinds of steps. So depending on the problem, how many number of steps it has to taken or it is taken by the particular problem, how many steps to be taken to solve the particular problem is the solution to that problem. Okay. So it is the rule. Here what? Here it is one rule in case of luxury. In case of express, it is 3 rules, 4 rules. In case of ordinary, it is a 10 rules. So here the number of rules are keep on increasing depending on the process. Okay. So that is what a precise rule or set of rules means. So the set of rules are precise rules. They are given to solve one problem. Given to solve one. So what is here algorithm is algorithm is not related to any computer language. Okay. It is not a particular to one computer language. It is what it is exactly. It is a sequence of instructions. It is what sequence of instructions. Sequence of instructions means what? Just now we discussed what one ordinary bus, source to destination, source to destination. This is the source, this is a destination. It will take 10 stopping points. So it stops at 10 different bus stops. So that means what? It will cross one bus stop, then only it can cross second. It reaches to second bus stop. Once it crosses second bus stop, then only it can reach to third bus stop. So this is what sequence. This is what sequence. So here also, the sequence of instructions, these are called instructions. So what they are doing is go to the first bus stop, then you can cross the second bus stop, then you can cross third bus stop. This is what set of instructions given to the vehicle by the driver. Okay. So instructions which give clear idea on how to write a computer code. So here algorithm's role is what? The algorithm job is it will define, it will define with some set of rules, some set of rules. That rules are called set of instructions which are giving to the computer with the support of programming language. The support of one programming language. Okay. The support of one programming language. An algorithm is having set of rules. Okay, that is fixed rules. Fixed rules. Okay, are given to computer with the help of one programming language. The help of one programming language, or you can see with the support of one programming language. Okay. So that programming language is Java. 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 So what we understood? So to write an algorithm or to develop an algorithm with the fixed rules or with some set of rules, the rules which are given to the computer, if we wanted to give any rules to the computer or any fixed rules to the computer in a systematic way or in a sequential way, okay, with the support of a programming language, that is with the Java, okay, that is called an algorithm. That kind of process is called an algorithm. You understand? So that is what is this algorithm is. So how to analyze that algorithm then? How to analyze that algorithm? How to analyze that algorithm? So starts once an algorithm is written in a language and validated for correctness. So we written the language, we written the algorithm in one language. Okay. Now here it is Java. So we written the algorithm in Java. Okay. Now we wanted to analyze that. Okay. Now we wanted to analyze, we wanted to validate its correctness. We wanted to validate its correctness. So it is the time to program the algorithm in some computer language. Here it's what? There are so many programming languages are there in the market. C++ is there, C is there, Python is there, Java is there, like that. So the program that implements an algorithm in some computer will consume various computing resources. Okay. Now what we did, we retain an algorithm in some programming language. Now to implement that in the computer, it requires computing resources. It requires computing resources. So the resources are called, one kind of resources is processor time. One kind of resource is processor time. So the processor, like, what is inside what are the resources we exactly required is ALU, arithmetic logic unit is required, and CLU is required, and memory is required. And along with them, we required RAM, we required hard disk, we required even graphic card, sound card, and other storage areas. Okay, other storage areas. You see here. Other storage areas. Other storage areas. Now see this. So what is the computing resources is? So one resource is what? Processor. Processor. In that processor. The second resource is what? Next resource is RAM. The next one is hard disk. The next one is graphic card. The next one is sound card. And next one is storage. Storage. These are the resources required to implement that algorithm program. Okay. Now, analysis of an algorithm is nothing but, so it is determining how much time. That means for that an algorithm, we have to uh, understand that how much time it requires. Okay, like how much space an algorithm is consuming to complete. Okay, so these two factors we have to analyze. First one is what? Time. Second one is space. Remember, we require time, we require space. Required space. Required space. Now see what exactly the space and time complexity is. What exactly the space and time complexity is. Space and time complexity. Now the amount of memory an algorithm or program memory means how much storage is required or how much processing power is required. Okay, so that is the memory. The memory, how much it is required for an algorithm or to program. How much memory required to an algorithm or to a program which needs to be run to complete, is known as space complexity. Is known as space complexity. Okay. The amount of computer time an algorithm or programs needs to run to completion is known as time complexity. So memory is measured with the space complexity, the time measured with the time complexity. Okay. The amount of memory for an algorithm or the program which needs to be run is known as space complexity. Okay. At the same time, the amount of computer time, the time for an algorithm program needs to run to complete the task is known as time complexity. So understood what is an algorithm and what are the programming languages are there in the market to implement the algorithm. Okay. So what are the computing resources required to run the algorithm? And what is the space complexity and what is the time complexity? These are very important to understand. So I hope you understand now. The algorithm is set of rules to solve the problem, or precise rules we can say, fixed rules we can say. So that is an algorithm. So the algorithm can be validated once it is written in any programming language. The programming language, the algorithm can be implemented with the programming languages which are called C++, C, Python, Java, others. Then the computing resources it requires to run the program or an algorithm is processor time, RAM, hard disk, graphic card, sound card, and other storage areas. Now this is what an algorithm is. Now we understood even space complexity and time complexity. So space complexity is what, how much memory does an algorithm needs to run, or how much memory the program needs to run. That is called space complexity. And how much time it requires to run is called time complexity. How much time it is required to run is called time complexity. Suppose you are traveling the distance from source to destination source to destination. Okay, this is a source to destination. If it is this destination reached by 2 hours, destination reached by 2 hours, this is called time complexity. Okay, and how much space is required on the road to travel this bus? How much road is required this travel this bus from source to destination is called space complexity. Okay. So that is time complexity and space complexity. Next one is performance evaluation. It contains two phases. One is performance analysis and performance measurement. Now see what is an algorithm we already discussed. The term algorithm is definitely a noun because this word is name of the some Persian mathematics author. Abu Za'far Muhammad Ibn Musa al-Khwarizmi. So this is the algorithm where it is derived from. It's a sequence of well-defined instructions written in any natural or computer language to solve a problem. So how do you define this algorithm is? An algorithm is sequence of well-defined instructions. Well-defined instructions written in any natural or computer language to solve a problem. So this is the definition you can understand with this. Characteristics. An algorithm has the following characteristics. Okay. An algorithm has the following characteristics. It should produce one or more desired outputs. What is an algorithm should do is an algorithm should produce one or more desired outputs. One or more desired outputs. Your output here is result. Your output is called result. Your output is called result. Your output is called result. So your algorithm may have zero or more well-defined inputs. Now we discussed the set of rules can be zero or more. These are actually rules. So algorithm, what it is doing is it may have zero or more well-defined inputs. And one more important is it must have clear and unambiguous. So what the each step of an algorithm should be is it must be clear and unambiguous. Okay. You should not write in unclear way. You should not write any ambiguity way. Okay, there should not be any ambiguity, and that should be very clear. That is unambiguous. And it should terminate after a finite number of steps. That is called finiteness. That means if an algorithm contains 1 to 10 steps, after 10th step is over, it has to terminate. It has to terminate. This is called finiteness. It is called finiteness. This is called finiteness. Next one is language independent. An algorithm should be independent of a programming language. An algorithm should be independent of programming language. Though there are no standards for writing in algorithms, generally is written between starts and stop. So we can write in any number of steps. So there is no standard like that. You have to write only within these many number of steps like that. So some people may start it with the definition and so on. So it may contain basic code structures. Okay. It contains basic code structure. It is not that it's not that unstructured. It contains some code structure. So if else or loops or do for while like that. So which are generally available in almost every language. The simplest example for an algorithm is addition of two numbers and display the result. Addition of two numbers. Addition of two numbers and display the result. Display the result. Now writing step numbers is optional and can be removed if don't want to prefer. So these many number of steps we are writing. If you wanted to show that, you can remove. It's not a mandatory. So you can write like this. Step one is start. Step two, declare three variables. Step three, read value and assign. Step 3b, read value and assign to it. Step 4, add values and step 5, enter the value. Step 6, stop. So it seems to be simple 6 steps, but in practical, it will increase little more. It is not that fixed. These many number of steps only the algorithm contains is not fixed like that. So it can be any number. It depends on the particular problem is. Okay. Now here the assignment can be represented with a left arrow. The input variable can be defined in the algorithm definition as well. Okay. Now examples here. Find the maximum of two numbers given by user. For this problem, they need to write the algorithm first, then they have to execute. The first step is they will start writing. Then second step is declare three variables. Step one is so it is finding the maximum of two numbers given by user. So first it will start. The next one is declare the variable of two numbers input that we have taken A and B. And next read the variables A and B. If A greater than B, display A is the maximum. Else display the B is the maximum. Okay. Declare display the A is the maximum. Else display B is the maximum. Display B is the maximum. So like that, you can stop here, can stop here. So for that, how many we are started and we declare the variables A and B. And after that, we read the variables A and B and we applied some condition A greater than B and displayed A is the maximum, else displayed B is the maximum. So, and we stopped that. Now, one more example here is finding the maximum of three numbers given by the user. Now here what we did, we have started and we stopped. Now at the time of starting, we declared three variables, A, B, C, and read the variables A, B, C, and we applied the condition if A greater than B, if A greater than B, else B greater than C. If A greater than B is true, again it will evaluate one more condition, if A greater than C, and display A as maximum. Else display C as maximum. Else B greater than C, display B as a maximum. Else display C as a maximum. And we can stop here. Okay. So this is one more example. Now one more example here is finding the factorial of a given number by the user. Now here you see how do you write the algorithm. How do you write the algorithm? First we start the algorithm and we stop the algorithm. Now in between this, whatever we write, these are sequential steps. So declare variable n, f, and I. The variable names can be any variable. So there are specific to the programming languages, the variables rules are defined. So with respect to the programming languages, we will discuss the variable rules. By following the rules, we can take the variable. This is called declaring. So declaration here means the variables are empty, no value. Here, no value, 0. Here, no value. Here, no value. So declaration means the variables are empty. Then after that, initialize the variables. Here, the variables are giving assigned with the some initial value. The initial value can be any initial value it is. Okay. Then read value of n. Read value of n. And repeat the next two steps until the I is equals to n. I is equals to n. So this is the one more algorithm. This is one more algorithm. Now, these are the multiple examples. So you take one example, you start writing the algorithmic approach like this. Then you will understand how to write the algorithms. How to write the algorithms. Now, analysis of algorithms or performance analysis here. Now, writing an algorithm is definitely an art. This process involves the steps. So first write the algorithm, devising and writing an useful and good algorithm. Now validate an algorithm that refers whether the algorithm produces the desired result or not for the given well-defined inputs. Okay. Now analysis of an algorithm is Once an algorithm is written in a language and validated for correctness, now it is a time to program the algorithm in some computer language. So, such as any computer language it is, say C++, Python, or Java. So, the program that implements an algorithm on some computer will consume the various computing resources, such as processor time, RAM, hard disk, graphic card, sound card, and other these things. Now, after that, space and time complexity. So, what is space and time complexity? We understood the amount of memory an algorithm or program needs to run to complete is known as space complexity. And also, how much storage, how much time an algorithm needs to run to complete a task is called time complexity. So it is the performance evaluation. It contains two phases. So one is performance analysis, next one performance measurement. The performance analysis in this phase, it estimates the program or desired derived mathematically. Okay. Then performance measurement in this phase, the testing is done based on the estimates. So analyzing an algorithm involves many formula and concepts from mathematics. So probability and stats, the algorithms analysis will give certain quantitative and qualitative judgment on an algorithm compared to the other algorithms. Okay. Now testing the program. Once the program is executed and analyzed, it is a time to test the program using debugging and black box testing and white box testing and performance testing, etc. So what we understood is what is an algorithm, what is an algorithm, and how to write or how to develop an algorithm by using multiple examples. Okay. And what are the characteristics of an algorithm? We understood the characteristics of an algorithm. And we also understood what is the performance analysis of an algorithm. How do we validate? How do we analyze an algorithm? And the next most important, also we analyzed that space complexity and time complexity. So what is space complexity? How much memory an algorithm or program required to run the particular task is known as space complexity. How much memory of an algorithm required or program to run or complete it is called space complexity. The time complexity is how much time it requires to complete the particular task is called time complexity. So that is space complexity and time complexity. And also we understood the performance evaluation. So here's example questions are given. You can answer to these questions. What is an algorithm is? What is an algorithm is? Just have to write here. The space complexity, how much space is required to complete one particular task by an algorithm. Okay, here see. Now, little more in depth, we understand what is space complexity here is. Now, basic idea we got is space complexity means how much space or how much memory it requires to run one complete task or one particular task by the algorithm is called space complexity. Is called space complexity. The space occupied by fixed part of the program. Space occupied by the fixed part of the program that is that part include the space occupied by the program instructions. Here what are we include is we include variables, we include constants, we include static and fixed size arrays. The space occupied by the fixed part is independent of number and size of the code, and variables that means independent of behavior of the program. So here the space occupied by fixed part of the program, because program contains so many parts. So in that part, what is the fixed part? What is a particular part is occupied. So in that place, these things will come. Program instructions, variables, constants, statistic, and fixed size arrays. The space consumed by the variable part of the program, this part includes the space consumed by the reference variables, and which are dynamic sized arrays, recursion stack, and any other code which depends on the behavior. Now, example you can see here. Here, this is here C is a fixed part here for fixed part, and V is the space of the variable part. This is, and this is the total space. This is the total space. And P1 is a program or an algorithm whose space is to be measured. So for the particular out of the total space of the particular program or algorithm, which is equals to the fixed part of the particular program or algorithm plus the the space of the particular program and algorithm. So which includes both total space. Now here C is example, some example if you see, this is data type float and it is some function, and this is variable f1 and variable f2 and variable f3, which is having the boundary condition here. It is open and closed, is having the block, and it is a return, which return this calculation, which returns this calculation. After calculating this part, it will return the value. Okay. So in this above this example, the function one, this is a function which is of total space of the f1, this variable, f1 variable, which is equals to f1 plus f2 plus f3 plus result. This is the C means what here? Fixed part of the, which is the space for fixed part. So here all, yeah, this is f1, f2, f3 result is fixed part. So that is a space. This is what f1 is a total space. Now, which is consumed by the only fixed part, which is independent or instant characteristics of the probe. And like this, one more program is there. This is, so just go through this. We'll discuss the remaining programs in the next class and with the Java. With the Java. After this program, you can write the answer to this question. Can answer to this question, what is space complexity? And after that, we'll discuss time complexity also. what is time complexity and so with this we can conclude what is space complexity and time complexity. And later on we'll discuss mathematical notations of a particular algorithm. So we'll have in the next class tomorrow. We'll continue in the next class.